everyone. I will start with a question. And I know it's going to be an awful way to start, but would you be able to estimate how would it take you to create a REST endpoint for a business person, no SQL experience, to just write a text, transform that into a SQL, call the database, and return that back into text? Okay, now that everybody's talking about AI and all of that, would you be able to do it? What is that? Think about it. Don't say it. That will be S, small, T-short size. It will be medium. It will be large. Think about it.
So to use it without AI?
The world is yours. Think about everything you can use. Okay. Hopefully, maybe we will change that estimation over the course of this session. I'm Victor Martin. I'm part of the product management for the Oracle database. Today I'm here instead of Corrado, that is sick and couldn't make it. So kudos to him, because most of the demos are done by him. Someone to follow, I will put the email there as well at the end of the session. Safe harbor statement, this is all product directions. Read the documentation before you do something meaningful in production. Common sense. I suppose everybody can understand what text-to-SQL means. It's just that natural language translation between someone with no experience with SQL building a SQL query and getting the response back. It's all based on part of the technologies that are being implemented now for LLMs, so all the transformations, architecture, and things like that. So we will cover a few things on the go. Historically, answering questions like this will take a little bit of time. It's not simple for a computer to understand that we are talking about views for a movie, that we want to break the view by movies, that we are filtering by a specific actor, a time frame. So if we look at this, the inference will be in that direction, and what we want at the end is the query, that query. That, I mean, if I have to build it, I think it won't take a lot of time, but probably you have to double check the names of the columns, the name of the tables, the foreign keys, and things like that. So let's see what type of information you need and what you would think on the bigger picture. You will have to do a translation on the fly. You don't want human interaction. You don't want someone with experience in SQL to just double check that the query is valid. As we will see later, the schema is probably not enough. We will see some of the string examples, but you can think about some of those tables that you find in your schema that is like, what this table is storing. You have to figure it out, do a describe, so on and so forth. It wouldn't be fair to talk about text-to-SQL if we don't talk about those benchmarkings. So you probably are familiar with the benchmarks for different LLMs. That is huge now, and it's a way to see how well it performs. So you retrain, you do the benchmark, and get a score of how good this is. So the biggest one for text-to-SQL is Spider. So if you search for Spider, the text-to-SQL challenge, it will come up, and there's an interesting paper on that. So take a look. The link is down there as well. You can take a screenshot if you want. There will be a few links here and there for different things, so you can take pictures there. And if you have any question at any point, I mean, I'll be on the Oracle booth as well, but you can ask on the go. So that is the way we benchmark as well our solution. It's not using Oracle database to do the benchmark, but it's good enough because it's cross-domain, and it uses a lot of different type of queries that you will encounter in the wild. And then we have one of the main features that I want to talk, that is the Select AI. So hopefully this will reduce that estimation you initially thought about. And select AI is just that select that you are familiar inside of the Oracle database. So this is supported by 19C. It was improved in 23 AI that we released very recently. And then we have a package that is the DBMS Cloud AI that we will see some examples as well there. It's very intuitive. Select AI, and then you will have the yellow part. The run SQL will execute the query, generate the query and execute it. Then the rest is kind of like easy to understand. The most interesting maybe for our use case, our estimation is the narrate. The narrate will generate the SQL, run it, and then the results will be translated back into text so that business person can read it like a report. And then explain SQL, we will see an example, but it will tell you the reasoning, why the query was created like this, so you can debug that part as well. So overview of the steps you have to do to accomplish this is to choose the LLM. We have different ones that we support. Probably more will come. So OCI Generative AI is the native Oracle Cloud service that will allow you to select different LLMs internally and generate text. Cohere is one of the engines. It's a partnership from Oracle. OpenAI, we all know about that one, and Azure OpenAI as well is the implementation from Azure of OpenAI. So you select the LLM, and then you specify the schema. So basically, what tables, what schema, what tables you are going to use for this generation of queries. Because in Oracle you have connections with other databases if you want, and that gets abstracted with tables and things like that. Even object storage can be done there, so the possibilities of reaching information is almost endless. I will do a pause here because probably some of you, maybe the ones that are more focused on security, will say, wait a minute. So I'm going to send my data to an LLM, external one. That doesn't sound good. And we will talk about the production gotchas that you want to understand. But think about it. You actually, the only thing that you are sending is the schema. Okay, what is enough? Maybe with the schema, someone can create a SQL injection and things like that. So those are the things that you have to keep in mind. This is the world where we live with LLMs, where you just dump a lot of data there and see what happens. Someone will create a prompt that you don't foresee, and you have to keep an eye on those things. But initially, you are sending a schema, you are sending the selection of the LLM, that's pretty much all. Now, for the flow of how to generate a SQL query from normal text, natural language text, you have to do the AI profile selection, that is basically selecting that LLM that we mentioned, and then the schema, the database metadata. The next step will be with that metadata and that LLM selection, you have the profile, and then you add the question from the customer. In this case, find the top 3 customer segments for those movies. That will be interesting for a marketing person. I just don't know, but they will ask this type of things. So you combine all of those in that second step, and then you will call that pluggable LLM, let's say. That response will come back, it will generate, it will be verified, run, and then the response will come back to the user. Okay, so that's kind of the idea. Going a little bit more deeper, is not a lot of things you have to do in the technical space in the database. So you can ask your administrator to do the first part, but it's pretty simple. It's the access control list. So you are adding an entry saying, okay, Oracle database, I allow you to make a call outside, and that is the host, that is the port, that's the entry. Happy days. The rest is like the principal name, basically the user, and then you grant permissions to those 2 packages that we are going to use later. One of them, on the user role, is create credentials. So for calling these services, you have to have a credential, that API key that you generated when you sign up, whatever the credential is, and you will put it there. With that, you should be able from the Oracle database to make a call to those services, the LLM, the pluggable LLM. A second step, after that, you are done with the configuration, pretty much. There are a few things that probably you need to do later, but that's pretty much all. The second step will be create the profile. That is step one from the previous flow that we saw. It will be selecting, in this case, just as an example, is the OpenAI, the GPT 3.5. You put the name, you put the credentials as well, the name of the credentials, the reference, and then you select the schema. So that part will be the schema, the business interactions, that's a table, inventory, specification, and you're pretty much done. The next thing, and this one is important, we will see it on the code, on the Spring Boot code. We will have to select the profile every time you make the call with select AI. Before that, you have to get the session and set that. So it's telling next query in this session will have to go with that profile that is pointing to the OpenAI, the coherence, or whatever LLM you are using. And those are some, to me, amazing examples, because be able to do a select AI run SQL, how many customers exist, and get that is very simple anyway. But you can get as well the narration version that it will tell you, and you can just put that in the response of a REST endpoint. And then the show query, the show SQL that will tell you exactly what has been generated before it runs, and the explain that will tell you, well, I select this schema for that reason, that table for that other reason. It will tell you I use that count start, I filter by this. It's a way to debug, to know what was happening. Okay. We were mentioning at the beginning that the schema is not enough. This is probably a very extreme case, but you will find this in the wild sometimes. Table 1, column C1, things like that. And this is not enough. So there is a little bit of help on the Oracle database side. So some examples will be to comment on tables or columns. So the red ones are important for do the joins. It will help the LLM to make the joins and knowing what table is the foreign key and so on. Everything else is just giving business information. You can do this in production. It's not going to affect to your data, to your queries. This is just annotations for Oracle database to know that you can use those columns for specific things and what type of information from the business point of view has. What will be like put the DBA and the business person together for a few hours and go over the schema and put some annotations here and there. A real use case, this is one of the Oracle apps, but it's basically for telcos. But basically it's a complex model, and you don't need to pay attention to all, but in this case, some of the examples that we will use for commenting the columns will be give that, like define the status of the process, the different options that you have. That will help the LLM to know what they are looking, how to filter, things like that. Questions so far? That's going to production. Okay, that's where we were discussing about security, and it gets nasty eventually, I guess. You have to trust the LLM. You need to know, you can create your own LLMs. That shouldn't be a problem, okay? But if you are using these LLMs, you have to trust that they weren't using bad intentional post in Stack Overflow, for example. That happens in ChatGPT or in things like that, the hallucinations, things bad can happen because at the end you are generating a SQL query that will run into your database, okay? You have a way to control that. You can filter what type of queries you are running and things like that, but eventually you will have to call the database from a prompt that someone created. That's where all the research and PhDs are investigating about the security of the LLMs. This is no exception. Going to production, you really need to understand that this is a business person that probably is an external user that you have no idea, or maybe it's someone internal that you can trust a little bit more, but still, you have to consider those things going into production, okay? Going a little bit on the code, everybody will feel familiar with this. There is no magic here. We inject the entity manager because we will need to unwrap the session and things like that. We will show an example later. But we are also calling this part that we saw before, that is selecting the profile, okay? This is before we make the call in that session. We need to say, Oracle database, we want to use that profile. So at that point, you can call a different LLM, or you can do whatever you want, but you have to do that. After that, a little bit of cleaning, nothing important, and then depending on a path variable, you will say, okay, this is an narrate, or this is a run query. So in this case, the narrate version is a method. You send the entity manager and the question and what is inside of that, and then you do the mapping. There is nothing there really interesting. But at the very top, you will see the SQL text. That will be the select AI narrate, and then the question. Full natural language, it's coming from the user. You will unwrap the entity manager for the session, you get the session, and then you just prepare. The reason for this is because it's Oracle JDBC compliance. This is nothing you cannot do, but at the same time, it's not JPA compliance, okay? So you need to get the session and do the call yourself, and then retrieve the result set. The result set is simple because it's text, so just take it and return it in the method. Simple enough. The full code and some examples, we will even share the implementation of one of the kind of like a microservice doing all of this with Spring AI. We will mention it later as well, but some of the examples and documentation is there, so you can take a screenshot as well if you want. A screenshot, yeah, you wish. A picture with your phone. And now I want you to think about what you can build with this, okay? This is just the beginning. Estimation for that nasty ticket was very simple. Now business people will think about options, okay? And I want you to think about your business and what type of things you can build with this, okay? So one example is, imagine that you have a back office person, someone internal in your company that has to do some tasks. And there is some business requirements. One of them will be the task rule. And the task rule will be, well, very, sometimes you find that in a Jira ticket. Encourage the customer to do these things. Imagine that you are recommending something through an email to a key account. In this case, it's kind of like social media for doing things or whatever. But there will be rules like, hopefully not some of those like the dog situation and things like that, but you are curating information from a customer, a real customer, an account, and you want to use that and use emojis and make fun of it. Okay, that's the requirement from the business. But you have also, from another table on the left side, you have a table where you have the customer information. So you can retrieve customer information to create a specific email for that specific person based on those tasks, okay? Imagine another good example would be for cybersecurity, that I have a little bit of background on that. If you want to make sure that people don't click inside of your company the typical phishing email, you can generate your own, okay? And send them internally. So you can imagine you put text of how it looks like, okay? And you send that email automatically from time to time, and if they click on that nasty link, then you have to do the mandatory training that take you there, okay? So you can automate all of that and create an email every time different, every time using LLMs, that is a nice email that looks probably valid, and you can tweak those rules to make it happen. So that's another use case. Think about it. Think about use cases that you can build on your own company. And that will be the end result. You can call the DBMS Cloud AI to generate that. So what you are sending is the tasks, the information in unstructured language, unstructured data, the language, and then the data of the customer. And all of that will get combined, and the only thing is the action will be chat. So it will create text that someone can cherry pick and put in an email and send it to a customer, or send it as a phishing email just to try to understand if they are going to be trapped by that email. Okay. Think about other scenarios. You can build absolutely amazing things with this. And now I want to talk about one of the new features you probably have here. It's more or less brand new, but it's getting quite popular, and it's the vector search, AI vector search. So for those that maybe are not familiar, imagine that you are creating from text to SQL. The S in SQL is structure. Imagine that you change that for unstructured. Okay, so you are going with text, and you want to query unstructured data. Okay, so as I mentioned, new technology, AI vector search, quite popular. There are a few databases supporting it. Oracle database is one of them. And what we are going to do is use, from that transformation architecture, we are going to take one little bit, that is the encoding of the text or image or audio, or there is any unstructured data, can be transformed in that vector that is a hyper-dimensional vector. Okay, and that will be all of those numbers will be representation of the semantic meaning. Okay, that's very important. This is not open search. This is not query for specific words, specific combinations of characters. We are actually query the semantic, the meaning of the sentence. Okay. A very simple, not accurate at all example of how this works is that if you have a curriculum, all of those numbers, the float numbers on that vector, will represent different qualities. I'm saying it's not exactly like this because it's not a one-to-one mapping. Okay, the education won't be on the position 2, on the second position 1. But it will be, for example, in experience, if someone has more or less 5 years of experience working at whatever, 16, could be 15, could be 14, could be something around 16, but the closest it gets for that specific dimension in the vector, the closer the meaning of the text will be. Okay? Simplification on 2 dimensions will be something like this. Again, not exactly how it works. It's way more complex. But if we have 2 dimensions, then the vector that points to the dog and the vector that points to the cat will be similar, will be close together. Okay? And if you do the query for something that is pointing towards New York, the distance with elephant will be bigger. Okay? So that's the way things will work in terms of querying for the vector search. The way you make the calculations, there are different options. You can select those specifically. You can say to the database, you don't really need to do the maths. You don't have to do that. But you can select different metrics to calculate that distance. Euclidean, we all know, like Pythagoras type of thing. Cosine using the angles, the dot product, that will be kind of like representation will be more like the projection of the one vector over the other, and that will give you a similarity. Manhattan distance is like if you are in New York and there is no direct lines to wherever you want to go, so you have to take the components of that vector. Okay, and then depending on how far you have to go on those components, you will be more similar if you are comparing 2 vectors. And Hamming is taking a look to the 2 vectors, saying it's different here, here, and here, for how much, and then you will get an idea of how similar they are. You select that, and the database will take care of everything. So why vector search is important? Because the alternative to do this, and probably eventually with the pressure, with AI, everybody has to go a little bit on this direction, is that the alternative will be to give away all your data to this beast and say, train on a specific, very expensive machines, keep it running for a long time. Every time you change something on the data, you have to retrain the whole thing. So it's not secure, it's expensive, it's not nice. With vector search, it's just a column for specific tables that you have a little bit of control over it. And then it will be simpler to make queries. So the trade-off with how expensive would be the other option is just this one is better for business. How vector search is supported on Oracle database is a new data type. You can put blob, you can put number, you can say bar chart, and now you can say vector. In this specific case, you go very specific. You know what embedding model, that's the part that is going to calculate the vector. So the embedding model will have different dimensions and formats. You can play around with that with getting specifically what you need. Or you can say vector, and the database will take care of that. So it's up to you. That one is maybe more flexible. Think about maybe in the future you will change the embedding model, you will change the way you generate the vectors, and that will change dimensions, types inside of that vector. So that's a good alternative, and the database will take care of the rest. How this works? Well, we are talking about the distance, the similarity of the vectors, and one example would be, well, you have that method, the vector distance, and you will say this is vector 1, vector 2, and this is the metric I want you to use, Euclidean, Hamming, whatever you are using. One example, for example, at the bottom will be vector distance between a tiger vector and a lion vector will be always closer than the comparison with a tiger and an apple. Okay, apple could be a PDF document, and the other one can be an invoice, and you are comparing. Okay, so actually, tiger could be a sum, the other one could be a sum as well, and you are comparing unstructured data just like that. A little bit of a real scenario example will be if you have to find the top 10 jobs for those positions, you can mix and match. You can say the first part, it's clear. Where the title is software engineer, we want only those positions, so you are reducing the scanning of the table. Location will be New York, once again, reduced, and then we do the vector search. Order by vector distance, you are going to compare the job description vector and also the resume. So your curriculum, for example, will be there. That is the query you create with that embedded model. You will create the vector. The vector will be plugged there as a parameter, and then we use cosine as an option, and then you get more or less the 10 first vectors that are similar to that with those conditions. Indexing, for those of you that want to go a little bit deeper, although the database will take care of everything, we need to think about getting the top K. There will be a trade-off between search accuracy and how expensive, the speed, how quickly you will get. So there are two strategies at the moment to do this. Both are kind of like the same old stuff that we have seen. A graph that will relate vectors that are similar, and the other one is the partition with a tree, and then everything that is on the same branch will be more similar. That's the indexing way. So yeah, those are the technical names. So if you plug this on Google, you will get a little bit more information, probably some links to Oracle documentation, and there is really interesting topics about this and papers. Okay, so there is one other thing that you have to do in terms of configuring the database. I haven't speak about that one, but probably it's kind of like easy to understand. Good moment for questions so far, ideas? Yeah?
So I have a question. I saw in the previous slides that, okay, the input is a question, and the select statement is generated. So the question would be, do you have an example for an insert statement?
Yeah, for insert, we will see an example of that. When we are discussing about Spring AI, that project that will allow you to work with all of this, with PDFs, transform that into a vector, and save it in the database, we will see examples of that with code, so you can understand the full process. I haven't talked about that because it's kind of related to this task that you have to do. So, any other question before we? Yep.
So in order to populate a vector database with, let's say, existing relational database data, you need to have an LLM in place, right, to be able to understand the context and to create those vectors, like what is similar, what is not, right?
Correct. And you can use JSON. JSON, for example, if you can translate your raw in a JSON file and you put that in the model, the embedding model, it will generate that. And there are other ways. There are different ways to do it. You have already your database. You can create that JSON. You can do a trigger every time something new happens. You want to update that. You add the column. You can do it step by step, getting comfortable on how you deploy the LLM. But yeah, that's the idea. Like every time you want to take relational or not relational text, you have to attach it. It could be in object storage. If you are in the cloud, you can put a reference to that. But the content will be understood by the embedding model. It will be generating the vector search, the vector, and then that vector will go into another column in that table. So you have the reference to the object storage, you have some data that is structured, and then that column that contains what you need, and the reference to the object storage. So you can retrieve that in your website for your user and things like that. Yeah, it's a new data type. You store it there and happy days. Inserts, updates, everything works as it was, and the index will be generated for those for you and things like that. So you can improve the indexing, changing from graph to the partitional one. All of that you can do it. So how are we doing with time? Yeah, good. What is left? Well, the embedding model. How the database know about how to translate whatever unstructured data into a vector. So you can put it, one example would be to put it in object storage. So that is the object storage from from Oracle Cloud, and you will put that file. That file is the embedded model, and that is a format for those embedded models. So you can plug different LLMs, let's say, or the embedding model of the LLM into that format. And that format is pretty standard. You can download some of the tools, Hugging Face, all of you download a tool that is from them, and you can say, okay, those are the files, the JSON, all the information that gives you the ability to call that method that will do the translation between unstructured to vector. Okay. This is a standard because you can create models for audio, for video, pictures, everything. So with unstructured data, we are meaning anything that you want. It could be JSON. So all of that, you pick the one you want, you load it, and then you put it with that other package, the DBMS data mining, import ONNX model. You put a name, you put the content, and then you say, and this is actually the metadata, you say, this is for embedding, okay? So automatically the database knows how to do it. You can do the same with another method that is specific for vector, but it's the same thing. You just take that model that you just compile, and then you deploy it in the database. So the database knows how to do that step. So with that, we have the ability to create queries from text with select AI. We create the connections to LLMs, so we can call that to get the query, the SQL query. We are able to create embeddings, vectors with embedding models. And now a simple example to use this one is with the vector embedding. That is the function to give me the translation of this. So hello will be the data, and you use that doc model. And then you just convert all of that to the data type, and that data type will be the vector. So that will be the way to just execute that to see how everything works and verify that everything was deployed correctly. At this point, because we are like the question, like what type of information, how you do the insert, one of the examples, if I have relational data, can I still do this? It depends. If you have the relational database, maybe in that case you can do a where, you know, it's a good one. But with vector sets, it will allow you to, you know, search on that space, on that direction. It's a multidimensional, you cannot draw it, but it's a vector space. So something that goes in that direction, you will get something that is similar, but not necessarily a strict where column equal whatever. Okay, you are just going in that direction. You don't know the patterns, and usually for some use cases, that's what you want. And because we are using relational, but also JSON and structured data, one interesting feature that we released on 23 AI is the JSON duality view. JSON duality view is, to me as developer, is so cool because if you have your enterprise Java application with relational, Hibernate, Spring, all of that, you still want to use that transactional part. But you can create that view with that selected, with that nested selects, to create a representation in a view in JSON format. So that will be another view that can be consumed from Rust, Go, Node, whatever you are using, other department building another application. And every time someone is reading or writing, independently of that, it will be ACID compliance, it will verify all the constraints, so you have the best of the two worlds, okay? And it's just creating a view, you know? It's not like you have to do some magics and redo all the logic in your database. It's just creating a view, something that the DBA will do almost every day. Another thing that works on the same direction that is usually interesting, if you have a Mongo application, you don't have to change the code, you just have to change the string connection and point to the Oracle database. An Oracle database will understand the Mongo protocol and make the translation into the JSON view. So you can have 3 different applications that they don't want to work together and make them work on the same data at the same time. And this is important because if you have those tasks with examples, with code, some applications will be written in another language, maybe some others will use the logic from the enterprise Java application, so you cherry pick the ones you want. If you want to try it now, the only important thing, if you are in Intel, Windows and Linux and things like that, you are good with the first part. If you are in Mac, like myself, so we have a little bit of trouble. There were some people asking about this at the booth down in the main hall. We need to use Colima, that is a simulation of the ARM. So the performance will, you know, be somewhere in the middle, not where you want it. There is a lot of effort at Oracle just to make it work in ARM, so hopefully that will come really soon. But you can test it, and if not, what I do is just deploy a small virtual machine and install it there locally for me on the cloud, and then I make the connection, and that's for me for the developer part. Okay, that's another option. And now, Spring AI, and because we changed the topic and we have time, I'll do a sip and wait for questions.
1, 2. 1, 2. Just struggling a bit to connect the part about the vectors to the part text-to-speech, text-to-SQL. Does this mean that using vectors I can, have some input somewhere and write, let's say, find me some animals close to cats, and then it will generate me an SQL query using vector columns, and then give me the actual result and do the calculations itself? Is it possible?
Sounds like magic, right?
Right.
It is like that. It will generate the where type is equal cat, or whatever the structure of the table is. So yeah, it's like that.
But I mean,
different from the vector. Okay, I'm explaining two things that can be combined: vector search and the embedding the text to SQL. Both things can work together. So the one will be select AI narrate from animals that looks like cat, and they will work very well with my breeding, whatever. Imagine that you are a cat breeding company, so you want to know which ones will work, which ones are available, maybe nearby, maybe you can meet with other breeders. I'm not sure, I'm going in an example that I don't know where I will end up, but that's the example I came up with on the fly. So you can query for those, the breeds that will work together with the ones you have, and select AI, and it will return to that user that is breeding cats. They have no idea about SQL, they don't want to learn SQL, and you can create an endpoint for those, and they will just query. That happens every day with I mean, technically it's the future. Every data warehouse company is doing something like this. It's allowing business people to make business questions and get business answers. Behind the scenes, yeah, there will be full scans on the database, there will be queries across different tables with joins, but you don't want to look at that. Even for yourself, like if you have to create a report with filters, for just more or less guessing what any business people in that position will ask to create a report and then export it into Excel and all of that. You don't want to do that. You can just say, this is your database with your knowledge base, use it. So Spring AI, I suppose you have heard about it. It's a project that allows you to work with those embeddings, to do queries to vector search, and you would say, okay, Victor, but what is Oracle database? It looks like it's not supported. So I'll show you an example of how to do it, because the interface is so easy that, I don't know, it's probably, there's no need for direct support out of the box anyway. But other interesting things, and probably the first you will use, or at least the most of the cases, when I was thinking about use cases, the most of them were like PDFs and things like that you have there sitting on object storage, and you want to understand what is there and maybe make them available, searchable. That will be the ETL pipeline, so allow you to just get the PDF and cut it into chunks and tokens for using the LLM concept, and then create the vectors, store it in the database, and then you can use them for query. So that's Spring AI. One thing that you have to do, you have to be able to make this type of brand new calls. For that you need the Oracle JDBC 11, so you import that, nothing new there. And then this is the interface for Spring AI. So it has these 4 methods. The other one is the same, different formats, but it's add, delete, and do the search on Similarity. So some examples of the implementation is the add, and that will be, well, very simple. I'll skip it really quick. You're creating the embedding. That variable shouldn't be with that name because we put it there and it's not the same name. This won't compile, but you can understand. So we are just doing that insert that we mentioned. So that is the way you get the insert. You add a new value, or you can create it depends. Some DBAs probably prefer like a trigger that create an update inside of the database, it's up to you. I'll probably go always for the Java version. I prefer to see that code, some procedure statement in the database. That's up to you anyway. And then the search implementation, the similarity search, is just making that query that we have seen with the vector comparison between two embeddings, the one from the query, the one from the database. This is one of the examples. If you want to take a screenshot, there is plenty of documentation, and there is a slide later with the demo, with the Spring Boot application up and running. No, not up and running, but the code and the link to the code, so you can take a look. But this is just the conversion, the tools that allow you to do that in Spring AI. And this is the example. If you want to take a look, there is the bit.ly link, the QR code. Those are the things that we are doing in there. But this is what we've been discussing. Just getting PDFs, getting the unstructured data, and finally be able to search for those documents. One demo that I want to do eventually is to be able to do the same with music. So I'm kind of learning piano, and I'm using a MIDI, so you can maybe collect the notes and maybe do the Spotify, the Shazam version of that. I'm not sure if it's possible, but it looks like it can be done. So I'll give it a try eventually. Time to go to production, and that is why Oracle is in this conference, and it's because we released very recently a production-ready Oracle backend platform for Spring Boot applications. So the way it works on-premise, on Oracle Cloud. It works on Azure. Even if you are using Azure and you want an Oracle database, you can use the Oracle database at Azure. But the thing is that you will have all of those technologies deployed in Kubernetes, in this case, in the OKE, the Oracle Kubernetes engine. And that will give you the distributed transactions manager, the API gateway. It will give you the workflow to coordinate microservices, observability with OpenTelemetry, Jagger, all the usual suspects. The way you deploy is very simple. I don't think we have time for play the videos and do the demos, but you can take the screenshots, the URLs. But it's basically you build your Spring Boot application, you go to the admin connection with a CLI and say, I want to deploy, more like Heroku thing. This is my jar, this is my version. Of you go deploy it, and you don't have to care about the container registry, all the details, pushing images, security, all of that. It will be taken care for you. This is the way it looks like. So you will have those properties, and then you will have the port forward for the Kubernetes onto the admin part, and then you will have access to that Oracle Aura CTL, and that will allow you to create the application name and then deploy that specific jar file that you just built. I will skip as well the demo, but you can just take a look on this. There is all linked. This is the resources. That probably the one slide that you want to take as a picture. The select AI information, you have there the lab that will guide you through the process of going through all of this. A little bit of information on the features of Oracle 23 AI for Java developers, something interesting in that document. And then the OCI marketplace. So the marketplace will have that Oracle backend for microservices, so you can say install that, and everything will happen behind the scenes. Finally, some step-by-step guide with a lab, like a lab format, for one scenario where we build microservices with that technology. So with that, you are kind of covered to investigate all of that. So hopefully at this point, in that estimation on T-short side has reduced of how to do these specific things. And before I say thank you and move to the next one, these ones are plushes. This is the pet for Oracle database, so I'm going to do the typical football thing and throw it somewhere. So who wants this? It's nice and soft. Let's go there. And then maybe here, one. Oh, it was like, so at this point, thank you so much. Thank you.